In today's video, we're going to be setting up the HereFlow optical sensor and lidar, the CAN version that I've bought from the ArduPilot set of accessories as well. So this little device, it's a little tiny circuit board. It's got a lidar optical sensor on it, and it comes with a CAN cable, which is going to make it super easy to connect into our CAN bus on our drone. So what this does is points down, from my understanding, and we'll use the optical flow camera to detect, how the drone is moving and if it's drifting. It should help keep it super stable when used in conjunction with the GPS, is my hope. Additionally, it'll have a lidar on it. The documentation does say the lidar isn't used for really big distances, but hopefully this will help to detect the distance to the ground for takeoff and landing, and maybe add some more precision control there and accuracy. Not quite sure yet. The other thing I have is on the GitHub page that I have for this, I 3D printed a case for this HereFlow device. Okay, and it comes in two parts, a top and a bottom, that you screw together with a couple screws then. So what that does is it gives it a nice case for this HereFlow sensor to protect the electronics and so forth, and give you some mounting screws to be able to connect it to your drone. So we'll get started here in a bit, connecting it up to the CAN bus, CAN hub that I got on my electronics workbench, and then we'll also do the ArduPilot configuration and see some of the sensor readings pop across into the display there. We won't be able to fully test if it's working or not because I don't have the actual drone frame ready to go, but we can test at least if it's getting basic readings and stuff, and then we'll fine-tune this stuff later after we mount it out to the drone and get everything working. So let's head on over to the bench and get this thing wired up. All right, so back at our workbench here, you're going to need a couple pieces to get this built. You need the HereFlow module itself, the CAN version, okay, and it will come with a CAN cable, and you're going to go ahead and just click that into the CAN port on the device. Okay, so I got that hooked together. Now the other piece that you need is this 3D printed case that I downloaded. Someone was nice enough to make this and design it and put it out on Thingiverse. So in the GitHub page for this electronic component installation, for this HereFlow installation, I have a link to this thing so you can download it and print it yourself. You will also need 3 M2.5 by 6mm screws so that you can connect the two pieces together. Okay. So what we're going to do is snap this in. Just fits in kind of with a little bit of friction. Okay. Make sure it's uptight. So I'm putting it into the bottom here. And then the top just goes over it. Okay, and I've already kind of pre-threaded these 3 screws a little bit just by kind of forcing them in and screwing them through for now. So we're going to take those 3 screws and we're going to tighten this thing down. Alright, and it'll look something like that. So now our electronics are pretty much protected. You got the camera and the optical flow sensor, the lidar components all exposed so that they can detect the ground and so forth. And then the only thing you got to do after here, which is what I love about this CAN interface on these ArduPilots, is I'm just going to plug it into one of my CAN bus ports. Okay, if you looked in an earlier video that I've done, I've got the Cube Orange on a core carrier board. I've got the CAN port on it connected to a Holy Bro It's the Holybro CAN hub. So that gives me 4 powered ports, so I don't have to draw the current from the core carrier board. And then from this Holybro CAN hub, I've got 2 of these CAN or I2C, I2C splitters that let me break this out even further. So on my CAN bus in total, I've got my GPS, my Here4 GPS. I've got 6 of these Hobby Wing motors. I have the Cube ID, remote ID solution. I've got a HereFlow, and I think that's everything right now. So it makes it really easy to just kind of expand what you have connected to your drone with this CAN interface. Okay, so that's really all it's needed, right? And we're going to go ahead and power this whole thing up. And by the way, if you're curious how I set all this other stuff up, this is video 9, I believe, of all the video series that I'm creating. So videos 1 through 8 will get you to this point, right, where you got your electronics prototyped on a board outside of the drone, so you can get everything working and tested before you install it all. So go ahead and watch those videos if you're curious how we got to this point. Yeah, and so after that, right, this is powered, it's sensing. What we need to do now is go over to ArduPilot and enable the rangefinder and enable the optical flow, and then we should be able to see in its telemetry display, you know, if I put my hand over it, it will be measuring the distance to my hand, and the optical flow sensor will be outputting values showing if the drone is moving, you know, in different directions. What that does is it kind of does an edge detection, computer vision algorithm, I believe, and we'll notice actually a corner detection, and we'll see if the corners are moving in one direction or another, and based on that it can tell, you know, if the drone is drifting or not, and utilize that. And I believe with sensor fusion it'll integrate that with the GPS as well, and be able to keep the drone very, very still in the air. The other thing that is supposed to be nice about this is if for some reason you lose GPS or aren't locked with your GPS, the optical flow sensor can at least help hold your drone stable by identifying the ground and knowing if the drone is drifting or not, and stabilize it. All right, so I think that's this component's wiring and electrical connections. We're going to go ahead and run over to the computer now, start to connect through our ArduPilot software, or Mission Planner software, I'm sorry, and we're going to configure the settings in ArduPilot to enable this thing. If you haven't seen the prior videos too, the way I've been connecting, you can of course plug a USB cable in if you want direct to your computer, but I'm also using the HereLink system. So I've got a HereLink controller here talking to a HereLink air unit, which all the telemetry from this Cube Orange goes through. Wirelessly comes back to the HereLink controller, and then on this controller I'm able to enable a Wi-Fi hotspot that my computer or laptop will talk to running Mission Planner, and it will be able to kind of bridge the connection. So my computer is talking through the controller all the way up to the air unit and core carrier board, so that Mission Planner configuration can be done pretty easily, right? I don't have to have any cables in this setup here. I'm doing everything wirelessly, which makes it really nice and easy to maintain. Also, I'm able to take the whole setup as is to the field and run it just like I would be, just like I've tested here for the most part. So, all right, I'm gonna head to the computer now and we'll get going there. All right, back at the computer, I have my Wi-Fi connected to the HereLink access point, and all the electronics are powered on. And so what we want to do is set the parameters to enable the HereFlow capabilities, right? So what I'm going to do is I want to direct you first to my wiki page. It's linked to in the YouTube description, and it'll take you here. And if you click on the documentation home folder, it's going to take you into the wiki folder, and there is a page for this video, number 9, the HereFlow. If you click on that, actually if you use the links over here, it should take you right into it. So if you click on 9 HereFlow over here, it will then take you into a page about this video and the supporting materials. Now, the ArduPilot configuration page that I have linked here is where I'm consolidating all of the parameters for all these videos. So you get one page that'll list everything you need to change to build a drone and with similar capabilities and hardware as mine. Okay. So if you scroll down, I've got a section for the here flow. Now what we're going to do, so let me kind of split the screen here. We want to go into our parameter settings. So I'm going to go over to config and then the full parameter list. And I want to search for these rangefinder parameters. So I'm going to type in RNG and hit enter, and you'll see I can find this rangefind1_type. Now notice these other parameters for the min and max centimeters are not showing up yet. You need to enable the rangefinder1_type and reboot for these other parameters to show up. So if I come over to rangefind1_type and I enter in 24, that should correlate to a drone can, but we'll write it and see. This drop-down should populate when we refresh. So if I refresh, okay, so there we are. Now we got a bunch of rangefinder 1 parameters. And in fact, I didn't have to reboot, it just refreshed the parameters. So you got to write the rangefinder1_type and refresh, and then you'll get all the other capabilities. So rangefind1_type is a 24, and you can see it's showing drone can. All right, so rangefind1 min centimeters, we want to set that. So we're going to go here. That's the minimum distance that the rangefinder can reliably read. So it can't reliably detect anything less than 5 centimeters away from it. And then the max centimeters is the maximum distance that it can reliably read. And this rangefinder on this device, it's not advertised for high distances or anything. In fact, the documentation, I believe, says it recommends another lidar, but you should be able to use this for precision landing scenarios, supposedly. That's about it. The other one we're going to do is set this rangefind1 ground clear to 10. So that's the expected range in centimeters that the rangefinder should return when the vehicle is on the ground. So you're going to have to tune that a little bit based on where you install it on your drone and kind of measure the distance from the installation point to the ground, or just grab the reading that it has and then put that in, because that'll tell you when your drone is landed or not. Okay. And then the other parameter we got to set is this flow type to enable the optical flow camera. So we're going to search for flow_type, and we're going to set that to a value of 6, and that should correlate to drone can as well. So with that, we're going to write all these parameters. Reboot is required. So we'll let this refresh, and then we'll go ahead and reboot. All right, so I'm now going to press Control F to bring up my actions window, and there should be a reboot Hexacopter button, and I'm going to go ahead and press. You'll hear the chime behind me when it reboots. Not rebooting yet. Let's try it again. Control F. Reboot. Yes. Well, that doesn't seem to be working right now, so I'm just going to pull the power from the device and restart it that way. Alright, you should hear it starting up behind me. We'll see if everything auto connects here automatically and properly regains communication. Okay, this appears to have reconnected. So what you can do now is from this main screen, you can click over in your status tab and you should have a couple values showing in here. Rangefinder 1 is measuring 136, or sonar range is showing at 1.36 now. And if I put my hand over it, you can see it's measuring much less. And as I raise my hand, those values are going up. Okay. And then the other one, if you go and search for the parameters that start with OPT, so these guys here, optical, the optical flow ones, if I move my hand and kind of wave it back and forth over the here flow, you can see the values are changing. So it knows what direction the copter's moving in based on how it sees my hand changing. So that's pretty much how you set up the here flow and enable the parameters. Now in a future video, once all this electronics prototyping is done, we got to mount all this hardware and do some fine tuning. But this gets it working in a very simple mode on the workbench behind me. So stay tuned for the next video. Be sure to subscribe if you want to see the future video updates and get notified about them. One of the next videos I'm going to be working on is potentially a TF Mini lidar. And I'm also working up a video where I'm going to try to set up an Ethernet switch, the switch block switch, and a Raspberry Pi, and connect all that to the air unit and basically get a little onboard Ethernet network on the drone. So that's all for today. Have a good one.